Hey, Steph.
I'm so mad.
What happened this time?
This jerk in my volleyball game kept blowing his vuvuzela every time I went to serve, and I missed every time.
Well, I don't know if that's actually why you sucked. Maybe you were just having an off day.
Elizabeth, come on. I don't have off days.
Everyone has off days, Steph.
You know what? We don't have to argue about this. Let's just test it.
That's a brilliant idea. We should test it.
But would it be a chi-square test?
No, it's definitely not a chi-square test.
T-test?
Are you kidding, Stephanie? There's no way it's a t-test.
Is it an inference about linear regression?
Are you kidding? It's definitely not that either. We have proportions, Stephanie. Let's be real.
I know. It's a 2-prob z-test.
Yes, that's it. It's totally a 2-prob z-test.
Haven't you ever wondered if loud distractions affect an athlete's ability to perform?
Oftentimes, athletes come up with all sorts of excuses for why they didn't perform well on game day.
In order to test this theory, we used a blowhorn to distract people while they attempted to perform an athletic feat.
We asked 11 girls and 11 guys, each varying athletic ability, from never playing a sport before to being the captain on the boys varsity basketball team, to shoot some free throws for us.
Little did they know, at any point they could be startled by the shocking noise of a blowhorn.
Blocked by gender, because you're interested to see if the loud noise of an air horn would have a different effect on boys versus girls when shooting free throws.
Using a random number generator on our calculator, we determined which shots we would choose to blow the air horn on. In an effort to maintain blindness, we didn't tell the subjects which shots we were going to blow the air horn on.
We then collected our results and put them into two tables, the girls' free throw results table and the guys' free throw results table. In order to carry out our 2-prob z-test, we had to fulfill several assumptions. The first one was normality, so we had to have at least 5 successes and 5 failures, which we had for both the guys and the girls' free throw results. But we also had to have independence, which is a simple random sample or a randomized sample.
We came up with 12 different hypothesis tests that we could run. For the 4 guy versus guy hypothesis tests that we ran, we rejected all of the null hypotheses, and we came to 4 conclusions about the guys. Guys make more free throws without noise than with noise. Guys miss more free throws with noise than without noise. Guys miss more shots than they make with noise, and guys make more shots than they miss without noise. In general, guys tend to follow the rule that a loud distraction hinders their athletic performance.
We could reject the next 4 hypotheses regarding only girls and say that girls make more shots without noise than they make with noise. Girls miss more shots with noise than they do without noise. Girls miss more shots than they make with noise. And girls make more shots than they miss without noise. The last hypothesis, that girls make more shots than they miss without noise, we could barely reject the null hypothesis with that since we got a p-value of only 0.047. This is kind of because a lot of girls that we tested weren't that able to make a free throw regardless of the noise.
Contrary to what you might think, we couldn't reject any of the null hypotheses involving girls and boys. It seems that the difference between gender is not significant. This is most likely because some of the female free throw shooters we had were extremely talented, whereas some of the male free throw shooters we had were a little bit. So from our experiments, we can conclude that loud distractions do affect the way you play. So I was right.
Looking back, we shouldn't have used a convenience sample, but since we randomized our data within our experiment, independence was actually met.
Additionally, we had some bias. The first one was that as our subjects kept shooting free throws, their free throw accuracy improved due to having more practice, as well as the crowd that surrounded our experiment provided positive moral support as well as some added pressure. Ha ha ha, I was right, Elizabeth.
Whatever, Stephanie.